Okay, this is a continuation of the examples I was trying to give you about binary to decimal conversion and vice versa. I've listed on the left some numbers, and so you can have 1 digit 0, or maybe 2 digits 0, 0, 3 digits. The most important one is just on the right hand side that has the value. The zeros on the left, or the leading zeros, do not have any value. So if you see the first three, I started with 3 digits and then I increased 1 0 on the left. So you can increase as many as you want because they don't add any value. I'm showing you these numbers so that you can see when we convert one binary number to a decimal one and all the way to 15. When we reach up to 10, if you're working with hexadecimal, then this will be called A, B, C, D, E, F. But for now, I just want to show you the general formula of converting the numbers. So if we start with, let's pick this number, and let's say this one, 10. So if I get that number 1010, the formula was strike or cross the first number, write it down here, and then times 2 to the power of how many digits are left. There are 3 here, so that becomes the power, and we put that in a bracket. Then we add the second number, it is 0. Put the 0 here and then multiply by 2, and the power is how many digits left here? 2. We put that power as 2, then we add, and we get the third number, which is 1, and then we multiply by 2, and the power is how many digits are left from there, which is 1, and then we add the last number, which is 0. 0 times 2 to the power of 0, no digits after that. Then we use the bit mass formula, bit mass, so brackets, index, division, multiplication, addition, and subtraction. Since we have a bracket here, we start with the bracket, but inside the bracket we've got multiplication and index, so we start with the index. So we keep the 1 times 2 as it is, but 2, we've said previously, 2 times 2 is 4, times 2 it's 8, so we have 8 there. 2 to the power of 3, now 8, and then we add 0 times 2 to the power of 2, so 2 times 2 it's 4, and then plus 1 times 2 to the power of 1, it is just 1 times 2, and then plus the 0 here, and then 2 to the power of 0 is 1. Any number to the power of 0, it's 1. Now we again do the pit mass, start with the brackets, and then what's inside the bracket, it's a multiplication. So we do 1 times 8, which is just 8, and then 0 times 4, it's 0, and then 1 times 2, it is 2, and then 0 times 1, 0 times 1, it is 0. If we combine them all, that's now 10. So if you see, the number we were working on is 1010, and it is in decimal 10, and that's how we found it. If we want to put that back to binary, from the previous example, we've said just put the number here and then divide by 2. This was multiplied by 2. Now we're dividing by 2. So if you divide 10 by 2, that's 5. Then there is no remainder. That means 0. Then if you divide 5 by 2, that will be 2 and 2 and 1 remainder. So the 2 as a division, and then as a quotient, you have a remainder of 1. Then if you divide by 2 here, 2 divided by 2, it's 1. Then there's no remainder. This remaining one, you cannot divide it, so you take it over, or take to here, and then if you read it from bottom up, that becomes 1010, and that gives you that example. If we do another example, let's pick number 13 or 15 if we want to, or any other number, just 11 let's say. And if we take 1 0 1 1, formula again was take the 1 times 2 to the power of 3 numbers left from here, so 3 digits to the power of 3, and then we take the 0 and we multiply, so you cross, so you don't mix which number you have taken, to the power of 2, and then bracket, and then you cross the other one, 2 to the power of 1 digit left, plus the last one, 1 times 2 to the power of 0. Then you do the bit mass, which is 1 times 8, and you put that in bracket, and then 0 times 4, you put that in bracket. You can just say 0 and 0, whatever there's 0, but we're showing all the steps so that it becomes something easy for you to practice and get familiar with. 1 times 2, and then plus 1 times 1. Now 1 times 8 is 8, 0 times 4 is 0, 1 times 2 it is 2, and 1 times 1 it's 1. So 8 plus 0 plus 2 plus 1, that's 13. Sorry, that's 11. And we're dividing 11 here. So we say 5. Let's just write it here, all of it. So we have 11 divided by 2. That gives you 5 and 5, but you carry 1. Then this gives you 2 and 2. If you divide by 2, that's 2 and 2. And then you carry 1. Divide by 2, that's 1. There's no remainder. And then you cannot divide that 1 by 2, so you carry it over. Now create it from there. So it is 1 0 1 1, and that's the correct number. The addition, I made the mistake. So 11. These are 2 examples, but if you have longer numbers, let's say this number 1 1 0 0 0 0 0 0, this gives you 192. The reason is, if you take 1 and 1 times 2 to the power of, how many digits here? 7. And that 7, if you multiply and then take the second number, 1 times 2 to the power of, how many numbers here? 6. And the rest will all be zeros, so you just put 0 there. 1 times 2 to the power of 7. In the previous video we've shown 2 times 2 equal to 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64 times 2, 128, and that is 128 times 1, so it gives you 128. And then 1 times 2 to the power of 6, which is 1 times 64, that means 64. If you add them and the rest are all zeros, this will give you 192. So if you see an IP address like 192.168.1 dot something, let's say 5, you can write it in decimal as 11000000 dot, and the rest you also do the same. So binary numbers, binary numbers, binary numbers. This is representation in decimals, representation of the same thing